Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about how we're going to make visualization through R programming. So in this video, I'm going to cover about how the R implementation should be done for creating this data frames and then data tables. And from that, I can able to explain how this histogram is going to be constructed through R programming. And next one, I'm going to see about the box plots and how we're going to find the mean, median, mode, and standard deviation, and quantiles and interquartile range. These are the topics I'm going to be covered in this video. So very first one is that data frame. So data frame is nothing but a table. So in which each column contains a value of one variable and each row contains one set of values from each column. And to create this data frame, so we can able to make use of data dot frame of function command that is going to be used, and then pass each of the vectors you have to be created as an argument to the function. Okay, so data frame is nothing but a table. Okay, so the data frame is nothing but a table, so which each column contains the values of one variable and each row contains set of values for each and every variable what I took here. And for creating this data frame, so we have a function called data dot frame of function, or it may be called as a command here. And each of these we can able to pass this vectors as an argument into this function. Okay, and suppose let's see the syntax for creating a vector. So vector is nothing but a character vector creating. So here the data frame name is this name and sorry vector, and for this I'm creating the name of the vector is C. So in this one I'm going to pass the names for the vector. It should be of character vector what I said. And similarly if I want to create a numeric vector, so similarly the vector name is H, then the name of the vector, and I'm going to pass the numerical values. So these are the values that is going to be stored in vector, and this is the variable where the vector is going to be assigned to the variable. So now from this two, I'm going to be construct a data frame. So how this data frame is going to be constructed? Data dot frame of name and then age. So these two are the vector. So this is one vector and this is another vector. So like this I can able to create a data frame by using the vectors as an arguments to the function, right? So then the outputs looks like this, like name and then age. So this one I'm going to treat it as one vector and this one is going to be treated as another vector. And so the entire thing what we can able to call it as data frame. So the data frame should be the collection of vectors. I can simply able to say that. Okay, so the vector is nothing but a group of characters, or it may be a group of values, numerical values. So this data frame can be created by using this vector. The name, the variable what I'm going to be suggested here, so that can able to take as the input or arguments from this data frame. And next one, how we're going to create the data table here. So the data table in R should be the enhanced version of data frame, and the main purpose of this data frame is to create a tabular data such as how the data frame is created. but the syntax is going to be varied here. Suppose I'm taking student information as the data table. So for that, how can able to create that? So for this, I'm going to take a variable, and this is the function what I'm going to be used for creating a data table. So the data table, and in this one, I'm passing two vectors, student ID. So that should be a vector of ID, student IDs, and age is another thing I'm passing as an argument for this data table. But the entire vector are going to be passed as an argument here for this data table. But in data frame, we just simply pass the names of the variable what the vector is going to be assigned here. So this data table is going to be hold two variables or two arguments like student ID and student name, and the student ID should be a vector which should be one of this argument of this data table, and age is also going to be another vector where can able to use as an argument for the data table, right? So the data frame and data table, so almost all same, but only the difference is that, so in data frame I'm going to pass the arguments, and but in data table I'm going to pass the entire uh, creation of the vector here. So that is the difference between the data table and then data frame. So the data table in data frame should be the enhanced version of data frame. So the main purpose is that which is going to be create the tabular data which looks like the same as the data frame here, but the syntax only the just varied here. Then we're going to see what should be the histogram and how this histogram is going to be created. So histogram is nothing but a visual representation of distribution of data set, and this histogram able to contains x and axis, y axis, and variable bars of different heights. Only the difference between the bar chart and histogram is that, so in bar chart we're going to be created a rectangular array which should be of some difference, and it should be having some space between them, in between each and every bar. But when it comes to histogram, it is not going to maintain any kind of space between these bars, right? So that is the difference between the bar diagram and histogram. So the normally these bars of the histograms, what we call it as bins. Okay, so the bars what I'm going to be drawn in histogram, what we called as a bins here. So normally you're having a data sets of air quality, so which is going to be has daily air quality measurements in New York City. So this is the data set what I took here. From this I'm going to construct the histogram. So for this, how I'm going to write it in our programming is that, so I'm just typing air quality. So and for this I'm going to be write it as ozone solar or dot wind temperature month and day. So this should be this ozone, and what should be the temperature and month and day I'm going to specify. So this is the data set. So these are the columns what I'm going to be having in this data set. So ozone, what should be the ozone layer value, and then solar value, and wind value, temperature, month and day. So this is the data set what I took. Then from this, how we're going to be construct this histogram, we'll see now, right? So just now what I said, so the histogram should be the visual representation of the distribution of the data set. And so this histogram is going to be constructed on x-axis and y-axis, which should be the bar should be of different heights. So normally the bars what I created, this histogram should be treated as a pings, and for this the air quality in New York I'm taking consider as input for this. So next, what I'm going to do that is, so I'm going to be separate this equal to the data what I am going to have. So that one is going to be represented in the form of strings of air quality, str of air quality. So what will happen? So all the thing what I'm going to have should be in the form of that. And if I'm going to specify this summary, this is the under command what I'm going to have to mention this, like what should be the summary of the equality of from the data set if I'm going to type it. So what should be the main attributes or variables I'm going to take it out, and what should be the minimum value and first quadrant value and median and value like this. Similarly, if I'm going to type str of air quality, what will happen is that, so it should be, so what are the values of each and every variable, and similarly for this solar wind temperature how it is going to be vary, and which month and which day it is. So like this I can able to know this various what are the variables and what kind of observations we have from the data set. Like this I can able to get it out. And next one, so from this, this is the data what I'm going to have, like, so from this I'm going to be take it out. So what should be the minimum value among the data set. From this, I'm going to take this data set as an example. From this data set, so here I'm going to what should be the minimum value, and then what should be the first quadrant, and what should be the minimum value of this. And from this, how I'm going to what should be the minimum value of mean and third quadrant, like this I'm going to be considered. So from this, how we're going to type this our programming code for this. So temperature I'm going to take it out. So from this temperature, air quality dollar temperature I'm going to take it out. So from this I'm going to type histogram of the temperature. So this is the function what I'm going to be have for this, for constructing the histogram. So histogram means, so the function what I'm going to have is HIST. So from this argument, the data set what I'm going to take, so that should be sent as an input for this. So based on that, this is the output what I'm going to get it out. Okay. So the data set, from the data set, so if I'm going to construct it, so histogram, so histof is the function for representing this. Then from this hist function, so what should be the additional data or what should be the additional parameters where can able to add it out. So previously I'm inserting the attribute like hist of temperature. So from this I'm going to specify the main heading will be like this. So maximum daily temperature at LaGuardia Airport. So this should be the title of this. I want to add to the histogram. Then I can able to write main equal to, and within the quotations I have to mention this the title of this histogram, and xlab is this. So what should be the label that is going to be specified in x-axis I want to mention out. So for this, the temperature in degrees Fahrenheit, and what should be the limited value size, and what should be the limited value space between this, can able to specify it, and then the what kind of color I can able to mention it, like dark magenta, and frequency, how much of frequency it is, like this. So here the main is going to be used to specify the title, and xlab and ylab is going to provide the labels for the axis, and xlim and ylim is going to provide the range of axis, and call is should be the define the color. Okay, so these are the some of the additional parameters what can able to be used for this histogram. So I can able to add the title of the histogram. So if I'm going to mention what are the labels, I can able to get it out in x-axis. and what should be the labels that should be get it out on y-axis like this. And I can even specify the color, what should be, whether it should be green or red or what should be yellow. So I can able to fill the bars of the histogram as well. And with this some more additional parameters what can able to add this here is hist of temperature. So heading I'm going to add it. So along with this I'm going to specify what should be this label of X lab and then Y lab. So the label what should be for X axis and Y axis, and X limitation, and up to that. So what should be the range X lim? So that means what should the starting should be 50 and ending should be 100. So what should be the starting limiter and then ending delimiter. And here I'm just change the color like light green, so that the bars the filled with light green color and frequency falls. And here extra parameter what I'm going to add it is a break here. So the bars oftenly called this as a bins here, but here so the bin width should be break that should be set off 5. So this is the additional parameter what I'm going to be added in this histogram. And another thing also I can able to do that, so where I can just change this value. Suppose if I'm going to change from 10 to 100 also I can able to specify where the value is going to be start from 10 to 100 even, and then the color changed and the border also changed it. So the border color should not, previously it should be black, right? So what I did, so I changed the border of the bars and the frequency should be false here. So this like this I can able to some extra attributes or extra parameters to the histogram. And another kind of the thing what can able to set it at here is the box plot. So here the box plot function is that function which is going to be used. So box plot of is the function which is going to be used to take it out any number of numeric vectors, and which is going to be draw the box plot of each vector, where you can able to even pass in the list or data from its numeric vectors. So like simple box plot. So box plot of air quality. So this is the air quality is the data set what I took previously. So from this I'm going to be considered as the attribute for the box plot. So based on this I can able to get the diagram of the box plot for each and every variable what I took from the data set. So in the data set these are the variables. So ozone value, solar value, wind value, temperature, month and day. So from this I can able to get the previously I can able to get the hist of function. So that should where I can able to get the hist of histogram, where here I can able to use the box plot here, so which can able to get this. So let's take make a box plot of ozone reading. So previous thing is STR of air quality. Now I'm going to construct this box plot of air quality and then ozone only, where I can able to specify only the single parameter, single attribute. So with the dollar I can able to separate it. So this should be the name of the data set. So followed by the dollar and then variable name. So many variables are available like ozone, wind value, temperature, day, month. If I want to see only the temperature, I can able to write it as air quality dollar temperature. So I can able to get only the box plot for the particular variable also. So you can see that about the median also going to be more dispersed, where you can also notice 2 or more outliers and the higher extreme also. So this should be the lower extreme value and this should be the higher extreme value. Okay, so like this we can able to construct the box plot values chart for this any kind of data set also instead of histogram. And next we are going to see how this mean and median and standard deviation how are going to do that. So what should be this R function code for this implementation of mean, median, mode, and standard deviation. So mean is going to be calculated, so normally by taking the sum of all the values and dividing with the number of values in the data series. So mean is nothing but, so we're going to have a set of values like this, and mean is going to be calculated by the sum of all the values that should be divided by the number of values. So this should be represented as sum of I equal to 1 to n x of I, and then it should be divided by n. So here x1, so that should be 30 plus 10 plus 20 plus 40 plus 50 plus 75. Total number of values is 6. So let it be, you can able to get some value. Let it be 50, 70, 110, 60, and then 250 by 6, 44. So roughly I can able to get this should be the mean value of this data set. So what should be the R code for work or command for calculating the mean? We can able to see now. So mean is the function and x is the value, and trim and na dot rm should be null. So where x is the input vector, so what I said, so this should be vector data, and trim is going to be drop the observation from the both end of sorted vector. So okay, so which is going to be drop some of the observation from both end of sorted vector. I'm going to take it as a trim here, and n dot ra, so that is going to be used to remove the missing values from the input vector. Na dot rim is used to remove the missing value. Suppose if the data is missed here, suppose I want to remove this, then I normally didn't get the data here, so at that time I can able to pass the vector, but by make use of this na.rm command, so I can able to remove the missing values from the input vector also. Okay, so the code for implementation of mean for this is mean of x comma trim na.rm. So where x should be the input vector, so which should be the sum of all these values, and n should be the number of vectors we had, right, and then you can able to get the mean value. Mainly this trim and na.rm is the two attributes that is going to be considered to remove the sum of observation and then to remove the missing values from the input vector. So let's take an example for that, create a vector. So x is equal to, so vector of some values, finding the mean. So result dot mean is equal to mean of x. So the output should be 8.22. So this should be the result of mean. And suppose how can able to use mean using trim. So here the trim parameter is going to be supplied, so where the values in the vector and this the number of observation are going to be drawn from the calculation. So from this, if I'm going to apply the trim, so mean of x comma trim, so what is going to be, it should be this, the value should be 0.3, and result dot mean, if I'm going to specify, then it should be 0.55. So similarly, next one, how we're going to be use this mean missing values, how we're going to be eliminated from this. So if you are going to be use this missing values, then main function is going to be written null. Okay, so suppose the input vector is going to be have some missing values, so what is going to be do? So the mean value is going to be written nothing. So in order to drop this missing value, so I can able to use of na.rm. So na.rm is this variable which should be make it as true, so that we can able to remove this not available values. So let's take an example like creating a vector, and then I'm going to calculate the mean and I'm going to get the value. So similarly, after dropping NA, so and make it as true, so the result should be 8.22. Okay, so how this, so these are the extra variables and parameters what I'm going to be consider here for this calculating the mean. So for this mean, I simply calculate the mean of x, or I can able to calculate the mean of x comma na dot rm is another thing. And next one is also trim. So trim is the function which can able to remove the number of observation that is going to be dropped, like so x dot trim, or I can also make use of the combination of all the three. So na dot rm equal to trim. And next one is this median. So median is this most value in the data series. So in order to calculate this median, I'm going to have a function called median of, which is going to be used to calculate this value in R programming. So here also I'm going to pass some of the attributes to the mean function, like median of x, and then median of x comma na dot rm equal to false. I have to write. So where here also the same. So where x is the input vector and na dot rm is going to be remove the missing values from the input vector. And from creating the this vector, and I can able to write it as median dot result is equal to median of x, where can able to get the value. And mode is the other kind of the thing which is going to be calculated. So normally this mode is going to be calculated based on the highest number of occurrences of the set of data. So mostly this mode is going to be have both numeric and character data. So but the OR does not have a standard inbuilt function to calculate the mode. So what I'm going to do is, so can able to create the function to calculate the mode of the set of data in OR. So how this the mode is going to be calculated on programming, like so get mode. I'm going to define a function of v. So unique value of this is going to be assigned, and from this we can able to calculate maximum of the tablet of match of v comma unique one. So normally how this mode is going to be calculated, so 10 20 30 10 40 50 and 20 10 10 50 90. So the more, how many times that 10 is going to be occur, 1 2 3 4 times. So 22 30 1 40 1 52 and 91. So the most number of occurrences of the data should be treated as the mode here. But we are in our programming, we should not have the mode function. So for this, what I'm going to do, I'm going to be define a function for this. So like function should be a function v. So how can able to define this mode, like unique function, I'm going to write it here. So for unique, I'm going to calculate so among this data set. So like this, I can able to calculate the mode also. And these are the set of vector input vector with the numbers I'm considering. From this, I'm going to calculate the mode. So for calculating the mode, so I'm going to have the function what I said previously, get mode. This is the user defined function what I created. So from that I can able to get this value. So from this previous data, the number of occurrences mode should be in 2. So 2 should be the answer. So instead of 3, 4 and 5, and then 1. And for this creating the vector with characters, so how the mode is going to be calculated. So for this character set, I'm going to be consider get mode of characters, and among this the result which character is string is going to be repeated more number of times. So 0 should be 1, and IT should be 3 and D should be 1. So the most number of occurrences should be IT, so that should be sent as an input output for this character vector of calculating the mode. So like this I can able to calculate this. And very last one is that standard deviation. So standard deviation means which is going to be measured the amount of dispersion of variation of a set of value, and this one is going to be used when you're going to dealing the values, when you're going to have the difference between the values and mean. Okay, so there should be some equation for this for calculating the standard deviation, like sigma I equal to 1 to n, x of I is the mean, sorry, each value, and this should be the mean value divided by n minus 1. So this is the equation what calculating for this standard deviation. So if I'm going to know the vector values and then mean values and number of values, so based on this result I can able to calculate the standard deviation. So just now I said the standard deviation is going to measure the amount of variation, how much it is for a set of value, and normally this one is going to be used when you're going to be deal the value and are going to find the difference between the values and mean. And this where S is going to be called as the sample deviation, and X n should be the number of observation, and x of I should be this observed value from the sample item, and x bar should be the mean of the observation. So like this I can able to calculate this standard deviation also. So let's take an example like these are the values. So and from this if I'm going to have a predefined standard function, what I'm going to be like this is standard SD of. So SD of is the function which is going to be calculate the standard deviation, and simply I can able to get the result also. But normally how can able to calculate? So first of all I have to calculate the mean value. So mean should be g4 plus 8 plus 9 plus 4 plus 7 plus 5 plus 2 plus 3 by total number of values 8. So if I'm going to divide I can able to get something I'm writing, so 20.4 like this. So from this I'm going to calculate this deviation of square root of 4 minus 20 whole square and then 8 minus 20 whole square like this, and then we have to divide n minus 1, that should be 7, and finally I can able to get 4. So like this I'm going to calculate manually the mean value of this standard deviation.
Like, share and subscribe. Hit the bell icon for more updates.